may I like to call upon Novacret, concrete that just got an upgrade. Novacret has developed a patented green concrete solution that promises stronger structures and smaller carbon footprint. Sustainable building at scale, that's their vision. Can I call upon stage Mr. Vijay Yashwan?
Hello, good afternoon. I know I'm standing between you and the lunch and you are hungry, but since I have another appointment, I had to request the organizers to allow me to go ahead and present this. So we are a startup which has been incubated at FSID, Indian Institute of Science, green binders for producing concrete, and using this kind of a concrete, we should be able to produce any precast products which we'll be showing you later. And as all of you know that water is the largest consumed natural resources, and the second largest consumed material is concrete itself. And I don't have to get into details of concrete. All the materials which go into making a concrete are all mined materials, and the production of Portland cement as a binder is a highly energy intensive material, and it is also responsible, it's implicated for giving out nearly 8% of the carbon dioxide emissions into the atmosphere. Out of the total 13 to 14% is the construction building materials. And if you look at this, whatever I told you, this is the hidden cost of the things, nearly 8% carbon dioxide emissions. And the other things is the production of Portland cement itself uses a lot of mined materials like limestone itself, and whatever be your efficiency of production in the cement factories, you will still end up in about 650 kgs for every ton of cement clinker that you produce. And the other problem is a lot of water is being used for curing, because curing is very essential as it is an exothermic reaction which is a hardening process, and it almost takes 28 days to attain its target strength. Now, can we produce concrete which is not going to have all these problems with much less carbon dioxide emissions, much faster gain in strength, and no water for curing? And the answer is yes, that is what we have developed, and that is Novacret green cement. Now, here again the advantage is we are only looking at the binder, and the binder that we are going to use here is it's a circular economy, which are using the byproducts of other industries as precursors and a proprietary activator which makes it a binder to produce the concrete, and the other ingredients are not changed. Now, this is the alternate green cement that we are talking about as 100% replacement to the Portland cement binder in concrete. Now, this is what I have already mentioned to you. You have the precursors, and a combination with that is the activator, and this will be the Novacret green cement. Now, if you look at let us look at it as an example to produce M40 grade conventional concrete. These are the ingredients. You have the binder, which is about 16%. We have about 50% coarse aggregates and about 28% fine aggregate, and a little amount of water, which is the one which is responsible for the hardening process or the hydration to take place. What we are doing, we are keeping things extremely simple. We are only changing the binder component, that is the Portland cement with Novacret green cement, and the rest of the things is the same. The process is the same, and therefore acceptability is much better. Now, what is the other thing that we can think? We are also using coarse and fine aggregates, which are natural mined materials, and the way we are consuming these mined materials, we will not leave behind to the next generation anything. That is not sustainability. We are supposed to leave behind to the next generation some of the natural materials, and they are not the owners of the planet. And in that situation, we are trying to see how much of C&D waste can be utilized as recycled coarse aggregates, and also other kind of industrial wastes as fillers in the fine aggregate, and this is also possible in order to produce these things. Now, all these things we're able to achieve. Look at the performance. Now, in the traditional concrete, the Portland cement as the binder, whatever amount of binder that gets in, if you are going to produce a strength, compressive strength of M40, same amount of our Novacret binder, we are able to achieve 2x performance, that is double the compressive strength. There is an advantage, enhancement in strength. When it comes to water absorption, which is durability parameter, the concrete, Portland cement based one has a water absorption which is about 1.5%.
with our Novacret binder, we are able to bring it down to 0.15%, which is a good indicator of the durability of this kind of a mix. Now, this technology has been validated at Indian Institute of Science in our own laboratory, because I myself was a faculty member. I was recently superannuated from the services, and me along with my other co-founders, which I'll show you later, and this has been validated in both IISc and NIT Surat. Now, this is the non-structural precast products with our binder, and these are paving blocks of different shapes, and you'll also be able to do the different shapes what I'm showing you, curb stones, saucer drains. You think about anything, we will be able to make non-structural precast products with our binder. And what, for example, Nova Pavers, you will save almost 2 kg of carbon dioxide for every square foot of paving that we do. Now, these are the code which IS code is 15658, and these are the prescriptions of the parameters of strength, abrasion, both compressive flexural strength, tensile strength, and our product is meeting all of them. Now, all this we are achieved with no cement, 0 water for curing, and we are able to achieve the required strength in just 3 days as against 28 days required for Portland cement as a binder. Now, what is that we have achieved? We have reduced the carbon dioxide emissions by 80%. It is not carbon neutral, but still some carbon is there. And circular economy, because we are using waste material from other industries. That is also extremely important, that somebody has to consume the waste, and the construction, civil industry is the best for consuming because of the large volumes, and thereby save the environment. Now, we are also be able to achieve this with about 15% cost saving compared to the products which are available in the market with Portland cement as the binder. Now, our offerings is finished products, the paving blocks, non-structural purposes, and also the green cement, similar to a Portland cement bag. Now, these are the product range that we can think of. It's our binder. Now, the target markets for both finished product and green cement, that is Portland, not the green cement, Novacret cement. Now, these are the orders in pipeline. Some 80 lakhs are already there, and we are expecting 2 crore orders in future, and a few of the stakeholders who are going to give us. Thank you very much. This is a team, and myself is Nanjunda. Other 2 are Nitin and Vijay, Yashwan, co-founders. Thank you very much.
Thank
for
you,
your
Mr.
patience.
Vijay. A round of applause from the remaining people in the audience. Over to you, jury, for the questions.
So, Mr. Rao, I think I've seen your video. I've also seen your website with this similar video, and I've also seen some of your other talks. I mean, congratulations, you have the same enthusiasm and strength as you put it. Every time you have explained your product, it didn't feel that I'm listening to it for the first time. Great. Nice to see that enthusiasm. My first question is, why are you restricting yourself to precast pavers? Why can't it go to mainstream construction for high-rise buildings, larger infra works?
Yeah, more R&D is essential here, even though it's a very good promising material. Unless we back it up with R&D, laboratory tests, so that to build our confidence that it can be used for structural purposes, we do not want. Right now, we are only looking at precast products, because safety is very, very important, and we have to look at it through more rigorous R&D tests in the laboratory.
And also, to add on to what sir mentioned, it has to be quality, has to be controlled. We want to ensure the quality is given for the finished product. So, which is why we are manufacturing everything in quality controlled environment, and then we are giving it to the end user, so that all checks are given.
So, you have a factory, you have a plant, or you outsource manufacturing?
For finished products, we have industry partners where we are manufacturing with them, and thus the binder we are manufacturing in-house.
And what's the plan 2 years down the line?
So we have a plan where first plant will be ours, then we will be licensing our technology to existing manufacturer itself, and we'll be partnering with the finished product manufacturers.
How do you scale?
A scale. Yes, sir. As I mentioned, first plant we will be having it in-house. Post that, in order to scale, we'll be partnering or licensing our technology to the existing cement manufacturers.
And what's the incentive for the existing cement manufacturers?
They're the one who wants to meet net zero first. They're the one who first thing is they want to attain net zero because of our binder production. There is no heating process, nothing where they immediately achieve with that. That's the one immediate incentive where they have to adopt.
Let me tell you the incentive. If you go on mining, I think there is an end. See, unless otherwise it's a renewable source. Water is not a problem because it's renewable. You have the season and water again comes back. We are not. Now, our mined materials are not going to remain with us. At some point of time, there will be no limestone. You can't produce cement without binder. Imagine civil engineering or construction industry without binder. Should you want to wait until such time and then do a knee-jerk reaction and pay 10 times what we are paying? Or should we start looking for an alternative?
Right. And do you plan to go? Sorry. Do you plan to go global as well? Because this seems like a very good innovation.
Yeah,
Yes.
there are certain problems with this technology. For tropical countries, it's very good because you don't have to use energy to cold countries. The polymerization is the process that takes place here. You will have to use some amount of heat, something like 80-90 degrees centigrade. So like what he was mentioning, a real structure, how do you provide the heat? For tropical countries, ambient temperatures itself is 35-40, it's good enough. Globally, yes, there are problems because climates are very cold. It may not be adaptable there.
To address, yes, we do have plans to go globally.
Unless it's a precast product, you can do, but not the real structure, in situ construction.
And time's up. Thank you very much, Dr. Nanjunda Rao.
Thank you.
Thank you, Vijay.
Thank you for your patience. Thank you very much.